Okay, this is, I know it's 2.2, but remember in 2.1 we did 2 content objectives. So this is content objective 3. I can apply the Pythagorean theorem to solve problems in 2D and 3D. Okay? So, Renee, we're going to talk about Renee. She plays softball for her college team. She went home to visit her parents for the weekend and took her favorite bat to practice at the batting cages. After returning to college, she realized she left her bat at her parents' house. The largest rectangular box Renee's father can find has a base of 28 inches. 28 inches by 18 inches. So that's the base of the box. Using the Pythagorean theorem to determine if Renee's 34-inch bat will lie across diagonal at the bottom. So they want to know, can they lay it in the box diagonally like that? How big's her bat? 34 inches. So we want to know, does this, 34-inch fit there? So what should I do? Remember, we have a squared plus b squared equals c squared, which is the Pythagorean theorem. Which one am I trying to find? A, B, or C? C. My right angle always points at C. So does it matter which one's A and which one's B? Nope. What do I always do? Remember? Least to greatest. I don't know why. Because C is always supposed to be the biggest is my guess. All right, so grab that calculator. What's 18 squared? 224? 324. All right, Mitchell. Hey, thanks for making it to class today. What's 28 squared? 841? What should I do next? Add them together. Do you agree with my answer? Yes, no? Did I add correctly? Did the math teacher add incorrectly? Am I good? No, I'm not? What did I do wrong?
74.
What? Oh, 74?
784.
784. I'm sorry, I must have misunderstood. There? Well, then that's definitely wrong. Now am I right? Yeah. Perfect. Equals c squared. So what's my last thing I need to do? Square root. So when I get that square root, and we're going to keep it a decimal because we're looking for 34 inches, what do I get? Say it, Kathy. What do I get? 33.2 inches. Is my 34-inch bat going to fit diagonally on the bottom like that? If I want it to lay flat on the bottom, is it going to fit? It's not, because I only have 33.2 inches to work with. Okay. The box is 8 inches tall. So notice now we're going 3D, right? Renee's father is hoping to put the bat at an angle in the box as shown by we'll go with the purple line because he wants to put it like that. Use the length of the base diagonal and the height of the box as the two legs. So see this guy right here? I'm going to do a different color here. Didn't we just figure him out? And you told me how big was it? 33.2. So do I now know this leg, and this is my hypotenuse? See, because this is still pointing at C. Does everyone see that triangle in there? Please tell me if you don't. Do we see this triangle? Okay, so A, I'm going to put as 8 squared. B, I'm going to put as what? Very good, 33.2 squared equals C squared. We already know 8 squared is what?
64.
What?
64.
64. 33.2 squared. Somebody? Anybody? Jesse, what'd you get for 33.2 squared? Oh, you think I can see that? That's impressive. Okay, well, what was it? Thank you. Whew. All right, so what should I do with these two? Add them together. Do you agree with me? Yes, nods are good, so I know that you agree with me. So what's my last step? Square root. What does my square root equal? How many inches do I have? What can I do? Kira, what'd you get? 34.1. Will my bat fit? Barely, but it'll fit, right? That was a lot of work, right, just to get this diagonal, do you think? We had to do the Pythagorean Theorem twice, right? Well, I will be honest with you. I didn't even know this formula existed till I was like 32 years old. There is a 3D formula. A squared plus B squared plus C squared equals D squared, where A, B, and C are the length, the width, and the height of the rectangular prism. Use this formula, so now we're going to use it. Do we have the length of the box? Right here, do we have that length? Do we have the width? And do we have the height? Again, does A, B, or C matter in this one? What's the only one that matters in this one, do you suppose? D, and it's going to be what? If C was the biggest number in this one, what do you suppose this one means? It's going to be the biggest number in that one. All right. And so what they're saying is, in a rectangular box, let's see if I can even draw something 3D. So this could be your A, this could be your B, and then this is your C. But the D is finding that diagonal. Does that make sense? Does it matter which one's A, B, and C? No. Okay, so I've got 8 squared plus 18 squared plus 28 squared equals D squared. I want you guys to try that. I want you to try it. The process is the same. All right. So what was your 8 squared?
64.
And our 18 was?
124.
And our 28 was? So I'm going to add all this together. When I add all this together, what do I get?
1,172.
So I'm going to go ahead and take the square root. What do I get D equals? Huh? 34.2 inches. Are these pretty close? Did I round this 33.2? That could make up for my little bit of difference. Wasn't this a lot easier to find that diagonal than all that? Yes, that's why the two formulas exist. And when we're trying to find a 3D shape, we're going to use this. When we're trying to just find a flat 2D shape, we're going to use this. Does that make sense to everyone? Okay. We're not going to do the back. Let's get started with our presentation. Just never know when we're going to get called down for pictures. It's not a very long presentation because if we already know the Pythagorean Theorem, we already knew that part. So the only new part we're adding is the 3D part. All right. Are we ready? So, just like I've been saying, our content objective, I can apply the Pythagorean Theorem to solve problems in 2D or 2 and 3 dimensions. Now, the only thing I don't want you to get confused with, when we do the Pythagorean Theorem converse, there's always 3 numbers, right? With 3D, there's always going to be 3 numbers. But you need to decide if you're working in 3 dimension or not. Okay. An 8-foot ladder is placed 3.5 feet from the base of a wall. How high up will the ladder reach? Round to the nearest tenth. Since we're talking about a story problem, we are going to round. Because does it make much sense if I say, oh, it'll reach up 2 to the square root of 6 feet? Does that make sense? No. But if I say 33.2 feet, does that make more sense? Yes. Okay, so picture this is your wall. This is my ladder. And here's the ground. They gave you this nice picture this time. Do you think you'll always get a picture? You have to be able to read and interpret this. So if we read it again, an 8-foot ladder is placed 3.5 feet away from the base of the wall. How high up will the wall go? So it only makes sense that this is the ladder, right? All right, so I hate it when they do it that way. I like missing a squared. Because my right angle always points at C. All right. So let's first take our 3.5 squared. Do you agree with this? Yes? 8 squared. What am I going to do now to solve this? I love that idea. Subtract the 12.5. Or 2.5, sorry. Agree with me? Or did I mess that one up? Double check my work. I mess up too. What do you think? Am I good? So now I need to take the square root. How far up that wall would that ladder reach? It says round to the nearest tenth. How far up the wall will the ladder reach? You're taking the square root of 51.75. What did you guys get for the square root of 51.75? 7.2. 7.2 feet. Not forgetting my label because it matters. What kind of problem was this? 2D or 3D? 2D. I was still working with a squared plus b squared equals c squared. All right, yours is very similar. I told you not all the time are they going to give you a picture. A ramp has a horizontal distance. I will say horizontal is this way. Vertical is this way. This is horizontal. So, a ramp has a horizontal distance of 10 feet and a vertical rise of 3 feet. Find the length of the ramp round to the nearest tenth. If I were you personally, the first thing I would do is draw a picture and start labeling what you know. Vertical. How did I draw a vertical thing? Which way's vertical? Okay, now label those. Read where's horizontal? Which way is horizontal? And which way matches that on your triangle? And then which way did I say is vertical? Which one matches on your triangle? This is Yeah. Mhm. This is horizontal, right? Which one of those lines matches horizontal? There you go. And it says, it has a vertical line of 3 feet, so which one is that vertical? Horizontal. Which line of mine matches horizontal? This one? This one? So this is my 10 feet. Vertical. So what am I looking for? A, B, or C? C. Three squared is 9. 10 squared is 100. Added together, you get 109. A lot of people get there? Yeah? So, what should I do next? Square root of 109. Somebody tell me the answer they got. 10.4. So my ramp is 10.4 feet. Okay. We only have about 12 minutes. So we're going to do one more 2D and then we're going to jump to 3D. Okay. A ship travels 320 miles due north. So if I'm going to just draw it as I read it. It's really right here. So a ship travels 320 miles due north. Okay, 320. Then makes a turn due east. Okay. East is that way. And travels 200 miles. How far is the ship from its starting point? So we're looking for this. Here's my right angle. Does it matter which one's A and which one's B? No. $200 squared. 40,000. 320 squared. Something I wish that was my salary? 102,400, do you agree? Still wish it was my salary? I add those together. I'd really take that as my salary. Now we square root both sides. What do we get? How many miles away are they? Perfect, Brennan, perfect. 377 miles, because it said round to the nearest mile. So they're 377 miles away from their starting point. Now, why they didn't just sail that way in the first place, beyond me. Okay, I know there's another one, but we're going to skip down because it's a Wednesday to the Pythagorean Theorem 3 dimension. Remember, when we have a 3D, this is A, B, C, and then this diagonal going from the top of the box to the bottom of the box is D. Okay? All right, let's try some of these. How long of an object could Simon put in a rectangular box that is 10 inches tall, 12 inches wide, and 20 inches long, round to the nearest tenth of an inch? Okay, so I'm trying to find that diagonal line of D. Does A, B, or C matter? Like, do I need to put 10 in for A, 12 in for B? Does that matter? All right, so 10 squared plus 12 squared plus 20 squared equals D squared. What is 10 squared? Very good. What is 12 squared? Very good. And what is 20 squared? 400. Very good. What should be my next step? What should I do with those three? Add them together. So 400, 500, 644. Do you agree? Final thing is I should square root it. Twenty-five point 25.4. Here's why. 3, 7. That 7 makes the 3 go up to a 4. In inches. Notice I'm labeling every time. All right. This one, next one, that was actually where it ended. And I didn't think one practice problem was good enough. This one doesn't have a story problem to it. I just want to know what's the biggest object I could fit in this rectangular box. Notice it's in millimeters. That's fine. But what's the biggest I could fit in that rectangular box? Damn right it's... What do you think of my setup? Can yours be in a different order? Do you agree with my steps so far? Yes? Yes? Make sure you're trying this when I'm giving you time to try it. Don't just sit there and wait for me to do it. That doesn't help you. What'd you get for D then? I 11 point, what'd you say? The 8 makes the 1 go up to a 2. So the biggest thing I could fit in there is 11.2 millimeters. All right, we're going to try this last story problem. I'm going to leave this one for you guys to try if you need to. We're going to do this last story problem. Notice they didn't give us a picture, right? So I'm going to draw it with you, but we're going to read it. Jason has a box that is 10 by 6 by 16. Okay, I have a box. If you're not good at drawing the boxes, that's fine. Let's kind of draw a line back from there. So we got 10 by 6 by 16. He has an object that is 20 inches long. Will it fit in the box? Why or why not? So will that object fit diagonally there? What do you think? So you're going to use, because we have 3 numbers, don't we? We're going to use a squared plus b squared plus c squared equals d squared. Tell me, will that object fit in that box? Tell me, will that object fit in that box? So actually try it. It doesn't matter which one's A, it doesn't matter which one's B, it doesn't matter which one's C. So you could do a 16 squared plus 6 squared plus 10 squared, or any order you want. I saw some really good work out of you guys. Your order can be different than mine. That's okay. All right, so we're going to add all of these together. And sorry I had to start going over it already because we're almost out of time. Do you guys agree with 392? So we take the square root of that, and I get 19.8 inches. So that doesn't answer my question yet. Will his object fit? His object is 20 inches long. This is 19.8. Will it fit? No. All right. We'll do stations tomorrow with 2.2 practice. You're all snazzy today, got your sweatpants, your jeans. Picture day. Oh, you're looking so snazzy.
Sheriff, approach the office, please.
Because Jonathan told me to.
No, you did not.
So I'll have to go to the office, please, and also Julia Behar to the office.
You got what?
I hate it. I'm actually gonna say there was 3 rounds. I'm actually telling you.